Good morning, everyone. In the previous lecture, we have solved the examples on how to find the complementary function. Now, let us solve some more examples on the complementary function. The given example is d cube minus 2d square plus 4d minus 8 of y, which is equal to 0. For the given equation, we have to write a. After writing the a, please observe the equation. The equation is a cubic equation. Therefore, I should get 3 roots. By the synthetic division method, we have to factorize it. Therefore, by the inspection in the previous lecture itself, I told how to take the inspection value, that is substituting the real values in the given equation, and it must be equal to 0, and for what value it is going to equal to 0, that is your first root. Here x is equal to 2. Therefore, the coefficient of m cube is 1, m square is minus 2, m is 4, and this is minus 8. 1 is 1 here. 1 into 2 is 2. Minus 2 and plus 2 will get 0. 0 into 2 is 0. 4 minus 0 is 4 itself. Then 4 into 2 is 8. Minus 8 plus 8, which turn to be 0. Always the last term will turn to be 0. Then our equation is m square plus 4 is equal to 0. Then m square is equal to minus 4. Then m is equal to plus or minus 2i. When plus or minus 2i is there, and this is also one root, therefore c1 e to the power 2x plus, this is imaginary part, c2 cos 2x plus c3 sin 2x. And next example, d to the power 4 x divided by dt to the power 4 plus 2 d cube x divided by dt cube plus d square x divided by dt square, which is equal to 0. For this equation, I am writing the auxiliary equation, that is m4 plus 2m cube plus m square of x, which is equal to 0. If I take m square out, I am going to remain with m square plus 2m plus 1. M square is equal to 0, and this, if I factorize, I am going to get roots as m is equal to minus 1 and minus 1. The roots are real and equal. Therefore, c1 plus c2 t into e to the power 0 t, and for 0 comma 0, that is c4 plus c4 t into e to the power minus t. For minus 1, this is minus t, and for this e to the power 0 t. Next example, that is 4d4 minus 8d cube minus 7d square plus 11d plus 6 of y, which is equal to 0. Again, it should be followed by the synthetic division method. And the last example is d4 plus 64 of y, which is equal to 0, which can be splitted in the form of a square plus b square, which is equal to a plus b the whole square minus 2ab. Therefore, m square to the whole square plus 8 square, which is equal to m square plus 8 whole square minus 16 m square. This can be written as, again, this first term as it is minus 4m square, and this can be written as m square plus 8 minus 4m into m square plus 8 plus 4m. The root of this equation, 2 plus or minus 2i, here minus 2 plus or minus 2i. This is imaginary, I mean complex. Therefore, e to the power 2x, c1 cos 2x plus c2 sin 2x. Here e to the power minus 2x, c3 cos 2x plus c4 sin 2x. Now, this completes the examples on how to find the complementary function. Now, we'll move on to the important part, that is type 1. Pi of the form e to the power ax divided by f of d. See, please remember the particular integral of the form e to the power ax divided by f of d. It means that the RHS of the equation, it will be in the form of the exponential. Okay, the first term how we have to follow means it will be in the form of e to the power ax, where a is replaced by any number. In this case, the denominator f of d, in the d is replaced by a. D is replaced by a, that is e to the power ax divided by f of d, which is equal to e to the power ax divided by f of a, where d is replaced by a. Suppose a is 2, then here d is replaced by 2. If f of a is 0, then I have to find f dash of a. Then that time the formula will become x into e to the power ax divided by f dash of a. Now when f dash of a is also 0, then it will become x square into e to the power ax divided by f double dash of a. Similarly, it continues. Now we look into the examples. E to the power x divided by d square plus 3d plus 2. E to the power x divided by the coefficient of x is 1, therefore d is substituted as 1 square plus 3 into 1 plus 2, which is nothing but 6. Similarly here, e to the power 3x plus 4 divided by d cube plus d square plus d plus 1, d is substituted as 3. Simplify it, you are going to get e to the power 3x plus 4 divided by 40. Now here e to the power minus x divided by d square minus 7d plus 6, which is equal to e to the power minus x divided by coefficient of x is minus 1, wherever the d is there replace minus 1. And simplify it, you are going to get the answer as e to the power minus x divided by 14. The fourth example, 4 to the power x is there. Here this e exponential factor is not there, exponential term is not there, therefore this I will write it as e to the power log 4x. E to the power log 4x, whatever the coefficient of x is there, that is substituted as d. Rest all the procedure same. This is also the coefficient of x is minus 1, substitute here, and you are going to get the f of a as 0, therefore I have to differentiate it once again. While differentiating the first time, the formula is x into e to the power minus x divided by the f dash term. Again in that f dash, you have to substitute x as, the d as minus 1, because the coefficient of x is minus 1. The first example, solve 6d square y by dx plus 17dy by dx plus 12y, which is equal to e to the power minus x. Write the auxiliary equation of the LHS part and RHS as it is. And find the roots of the LHS part by the complementary function how we have solved before. That is, the roots are m is equal to minus 4 by 3 and minus 3 by 2. Write the complementary function for these two roots, that is c1 e to the power minus 4 by 3x plus c2 e to the power minus 3 by 2x. And this is your yc, that is nothing but complementary function. Now I have to find the particular integral, that is RHS divided by the auxiliary equation. RHS is e to the power minus x and the auxiliary equation is 6d square plus 17d plus 12y. Here the coefficient of x is minus 1, therefore the d is substituted as minus 1. Simplified, you are going to get the answer as e to the power minus x divided by 1. After finding pi, that is nothing but yp, you have to write the complete solution y is equal to yc plus yp. This contains 1 mark. Please, after finding the complementary and particular integral, combining you have to write the complementary function and the particular integral, then you have to get the complete solution, that is general solution. Now we look into the next example, that is y double dash plus 4y dash minus 12y, which is equal to e to the power 2x. As usual, write the auxiliary equation RHS as it is. For the auxiliary equation, find the roots. For the roots, you have to write the complementary function, then take the yp, that is RHS divided by auxiliary equation. Here in this case, f of d, that is coefficient of x is 2. When I substitute 2 in this auxiliary equation, it is going to be 0. Therefore then when it is going to be 0, then I have to find f dash of a. When I have to find f dash of a, I have to multiply x into e to the power 2x divided by f dash of a. In the d, I have to substitute 2. Then you are going to get the answer, that is x into e to the power 2x divided by 8. Therefore y is equal to yc plus yp. Yc is this and yp is this. Combining these two, you are going to get the complete solution. For more example, we will solve in the next class. Thank you.